Well, hello there. I've got something for you tonight, or rather today, or whatever time you're watching this. That's right. Let's play a game. I've got something for you. Now, I've been thinking the end of the quarter is coming up, the end of the school year, the end of our time together. So let's play a little bit of a game. Let's have a little bit of a wager here. See how you do. Here are the rules. I'm going to add points to your grade. Because I'm that kind of nice guy. But only if you correctly guess the card that we draw. So I'll shuffle these fairly. You get to guess. If you guess correctly, now, forgot to mention, I've only got the ace through the 10. Make this a little bit easier for you. So we've got the ace through the 10. I mean, there's 40 cards in the deck. You guess the rank correctly. So if you guess the card, ace 2, 3, 4, 5, 6, 7, 8, 9, 10, you get 3 points. But if you guess the rank incorrectly, you lose 1 point. Simple rules, right? You guess the card, you win 3 points. You're wrong, I'm going to take a point off of your grade. I like doing this, don't you? So here, let's go. Shuffle it one more time for you. Top card. You guess it correctly, you get 3 points. Now, of course, here I'm going to actually need you to let me know that you guessed it correctly or incorrectly. I can't actually watch you through there. But you guessed correctly, you let me know, I'll give you 3 points. But if you guessed it incorrectly, let me know, I'm going to take a point off. All right, you ready? It's my Mongolian cards again. Aren't they great? Check them out. But did you guess the 8? No, you didn't. You just lost a point. Let's play again. Ready to guess? Did you guess the 9? No, you just lost another point. Let's do this again. Did you guess the 3? In its flying eagle pose? Yeah. No, you just lost another point. Ooh, 3 points down. Well, if you get the next one, you're back to even. You want to go for it? Right now, you're a little bit, I've got a 1 out of 10 chance of getting things correct. 1 out of 10 chance of getting 3 points. But that means I've got a 9 out of 10 chance of losing 1 point. Well, because there's 40 cards and there's 4 correct values, so it's down to 1. Let me help you out. If that wasn't really your cup of noodles, still stack of cards. If you guess the suit correctly, I'll give you 3 points. But if you guess the suit incorrectly, you lose 1 point. Suit correct? Oh, there's 1 out of 4 because there's 4 suits. So our ace, hearts, clubs, spades. You guess one of those correct. Ooh. 1 out of 4 chance of getting it correct instead of 1 out of 10. It's a little bit better. There's a 3 out of 4 chance of getting it incorrect, though, compared to only 9 out of 10. Let's try it. You working at home, guess it. Did you guess the spades? No, you just lost a point. We can keep on going for this. But for the sake of time and my dying computer battery, we're going to move on a little bit. Still, that you're like, ooh, maybe I'll go for it, maybe I'm not. It seems a little bit risky. If we try another thing, instead of guessing the rank, instead of guessing the suit, what if I just ask you to guess the color correctly? All of a sudden, 3 points for guessing the color correctly. 1 point for guessing the color incorrectly. Well, if you got 50-50, that seems like a good bet. Now what's going on here is there's this threshold. You've had a 1 out of 10 chance of getting something correct for 3 points and 9 out of 10. So 10% being correct, 90% being incorrect. 25% you get 3 points, 75% you lose 1 point. Here, 50% you gain 3, 50% you lose 1. There's a line in here where it's actually worth your while to make a guess. So like how many points makes it worth the risk? And this is what I want to look at tonight. Where's that line where it makes the risk? This risk management thing, this is the idea of we're going to be looking at something called expected value. And expected value is the idea of what actuaries do, insurance adjusters, business decisions are made. This is mathematical probabilistic risk management. In the idea that if we know kind of the likelihood that something's going to happen, balance it with the reward versus the risk, we can make a decision based upon that. Most of us, you pay your car insurance. Now, why is your car insurance $1,500 a month? Well, because you are a 16-year-old male driver in high school with no driver's ed. You're going to get into an accident. My insurance, I'm a boring old teacher. My insurance is lower. I'm less likely to get into an accident. And so these probabilities balance with the values and the risks and the rewards to the insurance companies and to you. It's the idea of what we're going to call expected value. So expected value here. Oh no, what did I do? Expected value is going to be the average outcome of an experiment. Blow that up a little bit. Now, if you repeat an experiment over a long period of time, this is going to be your average result per trial. So your expected value. What do we expect to kind of get out of something with a reward? So we're going to find this by computing the expected value of an experiment is computed by multiplying the probability of each outcome of the experiment by its value and adding the results. So in math speak, expected value EV, using this Greek letter S sigma representing sum. It's the sum of all the products of the product of the probability of an event with the value of an event. Now that E sub I is just event I. I use a subscript I to indicate event 1, event 2, event 3, so forth. The probability of that event, the value of that event. Let's look at a couple examples here. So, get rid of that for a moment. So here we've got multiple choice exam, 4 possible responses to each question. You get 5 points for each correct answer, but you also lose 3 points for each incorrect answer. You get nothing if you leave a question blank. What is the expected value? Is it worth your while to take a guess? Just like, is it worth your while to guess what card I'm going to draw? Now, I'm going to set this up every time with a table, looking at the events, the probabilities, the values, the products, and then I'm going to add everything. Now, in this case, we've got a multiple choice exam. There's really 2 possible outcomes. You could answer incorrectly, or you could answer correctly. We're going to identify the probabilities for each. Now we've got 4 possible responses to each question. So the probability that you guess and answer correctly would be 1 out of 4. The probability that you guess and answer incorrectly would be 3 out of 4. We look at the values of each of those events. Well, the value of being correct, you're going to get +5. The value of being incorrect, you would lose 3 points. So we've got the probability, we have the value. We're going to find the weighted average, the expected value. We take those and we multiply. So the probability multiplied by the value, 1/4 times 5 gets us 5/4. We take the probability, multiply it by the value. 3/4 times -3 gets us -9/4. So we find all of those products, and then we're going to add them together. So we find the sum. So it gives us 5/4 plus -9/4, that gets us -1. Now interpretation, that means that the average result of guessing is you lose 1 point. Now you're not actually going to get 1 point down for anything. You're either going to get +5 or you're going to get -3. But the average is that you're going to lose 1 point each time that you guess this. You are likely to lose points by guessing. Let's take a different example. Now we realize, okay, what is our expected value? If we know that two of those answers are false, definitely. It's like, what's your favorite math class? Discrete math, pre-calculus, ceramics, or poetry? Well, obviously ceramics and poetry are not my two favorite math classes. It's got to be either discrete or pre-calculus. If we can eliminate some things, what about guessing at that point? So here, we've got the same two options. Either we're going to answer incorrectly, or we're going to answer correctly. So I've made a list of my possible events. What are the probabilities of each of those? Answering correctly, the probability is now 1/2. Answering incorrectly, the probability is now 1/2. The value, still +5 or -3. We find the product, 1/2 times 5 gets us 5/2. We find the product, 1/2 times -3 gets us -3/2. And we add those. We get +1. That means in this case, the average result of guessing is to gain 1 point. You are likely to be in the positive. Now, you're not going to get exactly +1, but if you were going to guess on everything, on average, you would be going up +1 point every time you guessed. It's better to guess in that case. Let's look at another application. School is holding a raffle with 1,200 tickets sold for $5 each. One of the tickets will be selected to win a jackpot of $2,000. 6 other tickets will be selected to win each $300. How much should you expect to win or lose on average if you buy one raffle ticket? Now what I'm going to do is every single time we do this, I'm going to put together my table. This helps keep me organized, so I have my events, my probabilities of those events, the values, the products, and then we're going to add them. In this case, we could win the jackpot. We could win a smaller prize, or you get nothing. We find the probabilities for each. Now there's 1,200 tickets. One of those tickets is going to be the big winner. Get 1 over 1,200. 6 tickets are going to win $300 each. We've got 6 over 1,200. Everybody else is a loser. The values. You win $2,000 if you win $2,000. If you win $300, you win $300. If you get nothing, you get nothing. We take the probability, multiply by the value, we find that product. So here, we got 2,000 over 1,200, we got 1,800 over 1,200, we got 0 over 1,200. We add those, we get 3,800 over 1,200. Now, of course, we're talking dollars now. So the average result is 38 over 1,200. That's, you win $317. So on average, every time you buy a ticket, you win $317. That seems off. What are we missing? Oh, the tickets cost $5 each. But wait. Tickets cost $5 each, as I just said. Wow. We need to take away those costs from the winnings. So on average, you win at $317 minus the $5 that you spent to get there. So on average, you lose $1.83 for each time you buy a ticket. Or in this case, the school gains $1.83 per ticket. So that we can consider the cost. Now let's go back to our car insurance. Now this is an overly simplified version, but let's say, okay, high school male junior wishes to purchase car insurance to cover replacement costs on a $15,000 vehicle. On the basis of accident rates for a specific demographic, the insurance company determines the likelihood of an accident and vehicle replacement as 4%. Now the insurance company wishes to make an expected profit of $100 per driver. How much are they going to charge you? Now they're not going to charge you $15,000 because then you would have $15,000 that you would just go out and buy a new vehicle. The whole point of insurance is that the risk is diversified. It's spread out amongst a full crowd. So again, I'm going to set up my table. The outcomes here, the events, we could get into an accident. We could have no accident. Looking at the tables, the probability of an accident has been determined as 4%, or 0.04. Probability then that we have no accident, no replacement cost, would be 96%. Value of replacing a $15,000 vehicle would be $15,000. The value of not replacing anything would be nothing. We find the product. We find the product. Didn't really need to do that. We add. $600 is our average payout. So on average, the company pays out $600 per driver. But that cost is transferred to you, along with the profit that the company wishes to make. So then the company is going to charge you $600 on average, in addition to the $100 profit that they want. So they're going to charge you that $600 basically on average that they're going to pay out. Now, not everybody's going to get into an accident because it's 4% are. So they're going to pay, you're going to pay the $600 plus the $100. You are on the hook for $700. All of this comes back, this is what we call expected value. Finding the expected value, the average outcome of an experiment. Now here I've got the fancy math talk, but it's going to be the sum of the probabilities multiplied by the value. Every single time, make a list of the events. What are the probabilities of those events? What are the values? Find the product, add, and interpret. What's the meaning in context? Think about any costs there as well. That was an awkward picture. Thanks for playing. I'll see you soon. Bye-bye.